So the first question is, a shaft is mounted on the ball bearing which is carrying a gear of 125 mm in diameter at its center. It is transmitting power of 3.68 kilowatts at 100 rpm. Allowable shear stress is 42 megapascal and distance between the bearing centers is 200 mm. Determine the size of the shaft. So diameter of the gear is D equal to 125 mm. Power is equal to 3.68 kilowatts at 100 rpm. Shear stress is 42 megapascal. So once the allowable shear stress is given, the design criteria would be based on application of Tresca or Guest theory, which is also known as maximum shear stress theory, that could be used, or else the same result derived out of these two theory is using the equivalent torque. So let me sketch the arrangement. This is some shaft supported in the bearings, and there is a gear mounted exactly at the center. So the gear is mounted right in the middle. Now, using the power equation and speed and diameter, we can calculate the tangential force exerted due to the rotation of gear. That is, power can be expressed as equal to P is equal to 2 pi n into T divided by 60,000, or else this formula could be also expressed in a different way. So instead of writing torque, I could write that as 2 pi into n. Torque can be expressed as tangential force into radius. So radius I'll be writing just before this, into radius divided by 60,000. So this becomes as P is equal to, that is pi into n into 2 times of r is diameter divided by 60 into ft by 1000. This is expressed in kilowatts. Now power is given as 3.68 kilowatts. So that is equal to 3.68 into 60,000 divided by pi into diameter. Diameter has to be in meters. This could be expressed as 0.25 meters. This is 0.25 into speed is n. This is equal to Fw, that is tangential force in. So now upon solving, we get the tangential force as equal to 5.6224 newtons, or this is also equal to 5.6224 kilonewtons it is, or this would be also 5622.4 newtons. That is the value of Ft. Now the tangential force is being calculated. Next is, due to this tangential force, the shaft will be subjected to bending. The shaft will be subjected to bending, and the tangential force will be acting right at the center. Now here the gear is given to us. So, and it is transmitting a power of 3.68 kilowatts at 100 rpm. So when it is transmitting the power, there will be tangential force as well as radial force, but radial force here cannot be computed. Reason is that for the gear, the pressure angle is not being mentioned. So for the sake of simplicity, or you could consider that this as a level 1 problem, and only the tangential load will be considered for computation of bending moment. Radial force can be ignored as the pressure angle is not at all given in the question. So instead, we could take this as a elementary problem at the first level. So bending moment can be calculated, that is equal to bending moment equal to the load is acting at the center, and let's say the distance between the bearing centers is L, and we could use the relations from the simply supported beam carrying a point load at the center. So bending moment for such case is given by M equal to WL by 4. Here W is Ft into L divided by 4. So Ft is 5622.4 into length of the shaft is given as 200 mm, which is also equal to 0.2 meters. So now this is multiplied with 0.2 whole divided by 4. So upon calculation, we would get this as equal to 281.12 into 10 power 3. 281 point, yeah, into 10 power 3 Newton per mm. Newton mm. Or else we could do one thing, since this length is expressed in meters, we could write in mm, and straight away we would get this as an answer. Okay, so this will be bending moment. Next is torque. Torque can be computed as equal to T is equal to Ft into radius. So Ft is 5622.4 into radius is 125 by 2. Radius is 125 by 2. That is 62.5. So upon calculation, the torque value will be equal to 351.4 into 10 power 3 Newton mm. This would be the value of torque. Now here allowable shear stress is given. So we are going to use Tresca and Guest theory or maximum shear stress theory, or else even if you calculate equivalent torque, this equivalent torque is derived out of using the maximum shear stress theory or Tresca and Guest theory. So TE is equal to root over m square plus t square. So 10 power 3 is common to both. What I can do is, I can keep 10 power 3 outside, and this could be expressed as 281.12 whole square plus 351.4 whole square. This would be equivalent torque, and upon calculation we would get that as 450 into 10 power 3 Newton mm. So equivalent torque has been calculated. Now using this equivalent torque, we can get the diameter of the shaft. So diameter of the shaft can be calculated by using the equation tau by r is equal to T by J. J here would be pi by 32 d power 4 and r would be equal to d by 2. So tau will be equal to 16 t by pi d cube. Let me tell you one more thing. Instead of t, it would be replaced with equivalent torque. So 16 te divided by pi d cube. So safe value of diameter is to be determined. So d can be, or subject to d, if we write, it would be 16 te divided by pi into tau. Yeah. 16 te divided by pi into tau raised to the power of 1 by 3. So this will be 16 into 450 into 10 power 3 divided by pi into tau is 42 raised to the power of 1 by 3. So this, upon solving, we would get it as 37.93. So now the diameter of the shaft has to be taken in the multiples of 5, or this could be rounded off to 40 mm. 40 mm would be the diameter of the shaft. So this was a simple numerical wherein you had only single arrangement on the shaft. Now let's try to understand if there are 2-point loads on the same shaft, and how is that we are going to proceed. Let me tell you one more thing. As a reminder, I am not going to consider the radial force. Tangential force will be there, which is going to cause the bending of the shaft. As in the question, the pressure angle, which is a parameter of gear, that has been not mentioned. So I cannot use the radial load, because after I know the pressure angle value, only then the gear is going to have radial force as well as tangential force. So we are just restricting the problem to a radial load, or to a load which is causing bending only in one direction. Okay. Now let's take one more problem, but in the next problem, we will be keeping the load in one direction, that is tangential, and the shaft will be subjected to bending only due to tangential load, or unidirectional bending will be taken into consideration. So next question, it is about a line shaft supported at its end in the ball bearings, that is carrying two pulleys, each of weight 1500 Newton, at a distance of 1 meter from each end, and it has to transmit a power of 100 kilowatt at a speed of 300 rpm. The distance between the center is 3 meters. Let me draw the shaft diagram. So this is some shaft given to us. And the shaft is supported in the bearings. Next is at a distance of 1 meter from each support, the shaft is carrying pulleys, and those pulleys has got a weight of 1500 newtons. So this is one pulley from the left support, and same way on the right support I need to mount the pulley. So let me just change the color. So this distance will be 1 meter from the left support, and this would be 1 meter from the right support. And the distance between both the pulleys is once again 1 meter. So this is a rough sketch, not drawn to the real scale. And the weights of the pulley is going to act vertically down. So the weights will be producing the bending in XY plane. Okay. So this would be another point load of 1500 newtons. Now, here allowable shear stress is given as 40 Newton per mm square. And once again, you are required to determine the diameter of the shaft. So let me just calculate the parameters which were common. So power first can be calculated. Power is equal to 2 pi into n into t divided by 60,000. So T is equal to P into 60,000 divided by 2 pi n. Power is 100 kilowatt into 60,000 divided by 2 pi into 300. So this, upon calculation, we get the value of torque as equal to 3183 Newton meter, or else 3183 into 10 power 3 Newton mm. Okay. So this is the value of torque. And next is, here you find the loads 1500 on the right side of the left support and on the left side of the right support. Both are equidistant. So hence, this is a case of symmetrical loading. So you should always try to take the advantage of symmetrical loading situation. Unnecessarily, don't try to calculate the reactions. The reactions at the A and B, let's see what it would be. RA is equal to RB, that is total load, which is 1500 plus 1500 divided by 2, which is 3000 by 2, which is 1500 once again. This is straight away due to symmetrical loading conditions. So when you write this point in the examination or in the answer script, when this term due to symmetry is being added, then the examiner understands that the student knows the concept properly. So these things you should always be keeping in mind. These are the hints which you are giving to the examiner that you know the concepts. So remember these things. Okay. So if you are interested, you can calculate the reactions, but there is no harm in that. But what happens is that you unnecessarily end up wasting the time or overdoing the problem. So which you should avoid. Now bending moment at A will be 0, but at this location C and D, it will be maximum. And the bending moment is going to be constant also. So bending moment at C or D, whatever the point you consider, it is same because of symmetry once again. That is reaction RA into distance 1 meter. That would be 1500 into 1, which is equal to 1500 Newton meter, or which is 1500 into 10 power 3 Newton mm. Let's try to check what would be the bending moment value in the middle. Let's say this is point E. This is just to confirm for you all that bending moment between C and D, it is going to be constant. So that is why I am doing this calculation. So this distance comes out to be as 1.5 meters. And if I calculate bending moment at E, it will be reaction Ra into 1.5 meter distance minus, because Ra is producing clockwise movement, minus 1500 into zero point 0.5 it would be. Okay. So Ra we have is 1500 into 1.5 minus 1500 into zero point 0.5. So I can pull out 1500 common from here. It is 1.5 minus 0 0.5, which is 1. So this is, once again, you are getting it as 1500 Newton meter. So whether you calculate at C or another point E or F or G, whatever it is, throughout the span, bending moment is going to be constant. Throughout the span, the bending moment is going to be constant. So you could check with any other points also. I have calculated in the middle, even at the C also, I got the same value. It's not going to change. So bending moment at C or D, it will be same. Now, next one, we have got bending moment, and here in the question they have given shear stress. So if shear stress is given, we have to once again make use of Tresca and Guest theory, or maximum shear stress theory, or the result that is been derived by using the above theories, that is Tresca or Guest theory or maximum shear stress theory. So the result that is been derived is nothing but equivalent torque. So equivalent torque, that is TE, is equal to root over m square plus t square. This would be equal to 10 power 3 is common to both, so we can keep this outside. So torque is 3183 whole square plus 1500 whole square into 10 power 3. So upon calculation, the value of torque or equivalent torque would be equal to 3.52 into 10 power 6 Newton mm. Newton mm. Okay. And now we'll use the torsion equation to calculate the diameter. So torsion equation, that is equivalent torque by J, equivalent torque divided by J, equal to tau by R. So this, upon simplification, you get it as 16 TE by pi d cube. J is pi by 32 d power 4, that is polar moment of inertia, and R is d by 2. So when you substitute these two, and if you try to simplify, you will be getting this as 16 t by pi d cube. Okay, let me do that for you. So TE divided by pi by 32 d power 4 into R is d by 2, it will be multiplied when it is shifted to other side. So 2 ones, 2 16s, 16 will go on the top. This is d power 1s and this is d power 3. So this is 16 TE by pi d cube. And if you write subject to d, it will be 16 TE by pi times of tau raised to the power of 1 by 3. So this would be 16 into equivalent torque is 3.52 into 10 power 6 divided by pi into tau is 40. Let me check the value of tau. Tau, yeah, they have given it as 40 raised to the power of 1 by 3. So now when you try to solve it, it would be 76.53 mm, or this could be rounded off to 80 mm. So this was another kind of numerical which had 2-point loads. So remember that if the complexity is been increased in the problem, they will also be giving you a point wherein you can learn to take an advantage. That point is nothing but symmetrical loading. So try to read the problem carefully and try to find the point wherein you can take the advantage while doing the calculation. So reading is must, and when you solve it by your own hand, then only you will be able to capture the concepts properly. I hope you have understood this session. If you have anything or any questions related to the concepts, please comment and hit the subscribe button in order to know more details regarding the concepts and more shortcuts from the other topics as well. Thank you everyone.